Hello everyone. How's everybody doing? Well, I hope you're doing better than me. I'm not doing so well. I still have a little bit of congestion. Been trying to get rid of it for a while. Sometimes it lasts 3 weeks on me. I drink hot tea, soups, keep myself warm, and it still takes time. It could be old age. I just want to say that sometimes my image goes out of focus, and it's the camera, no doubt about it. It's a brand new camera in the sense that I've had this problem ever since I bought it, and I bought it like, I think October last year or something like this. And for some reason, it just sometimes goes out of focus, and it's easy to get it back in focus. You just got to turn it back, off and back on, and then it comes back into focus. But otherwise, it doesn't seem to adjust itself all the time. Okay. Anyways, I want to continue with, just want to mention one more thing here, and that's that we're going to go to Lion Country for our next 8th Rational Physics Conference. It's going to be in Lusaka, and that's in Zambia, and we're going to be among lions. So if you ever wanted, or like my wife, she has it on her bucket list that she wants to go on a safari, kill some crocs or giraffes or whatever, this is your chance. And we're going to be there probably anywhere between January and February in that time frame. So if you had that idea of going to Africa sometime in your life, well, this is the time to do it. Okay, plan it ahead. You got several months, and as I said last time, I think there's several airlines that travel in that direction, not directly, but indirectly through some other African countries, usually, or I think one goes from the Emirates all the way down there. So if you're interested, that's the time. Okay, so what I want to talk about today, I want to talk a little bit about where I left off the other day, which I really skimmed along the top, and that's extinction. And then I'm going to get into some of the questions or some of the comments that were made about the physics aspect of the last lecture, okay, about the foundations of physics. Okay, on with the first one. Let's go with extinction. What's the theory? The theory that I'm proposing, okay? So you won't find this out there. This is bgaede's theory, okay? And the theory has to do with extinction, not with man. It has to do with what happened thousands and thousands of years ago, millions of years ago. We want to know how the animals and the plants and animals disappeared millions of years ago. So yeah, we're going to use this for man, but right now people have to stop thinking about man and focus on animals and plants and animals. Okay, so what is the mechanism that I'm proposing, the theory? What is the physical cause, essentially? And that's how it relates to physics. Paleontology, in that sense, is a branch of physics. And the cause is the disappearance of plants. Okay? You remove the plants, the herbivores die. You remove the herbivores, the predators or carnivores die. Very simple, really. And no one has ever discovered that. And you say, Bill, yeah, I've heard of that. No, you haven't. What you've heard is that there was some kind of accident that triggered the disappearance of plants. That's what you've probably heard. There is no theory out there today that says plants disappear on their own without an act of God. Without an asteroid, without volcanic activity, without a supernova, without something triggering it. There is no such theory out there. And that's where the difference comes in. So listen carefully. There was no act of God, there was no accident, no volcanic activity, no asteroid, no supernova, no plumes, no climate change, no disease, none of that nonsense. None of it. Plants disappear, animals disappear. So now we have to explain why do plants disappear naturally, without any accident, without any act of God, just naturally. Plants will die periodically. And that's the history of life on Earth, essentially. So let me just go quickly over that. Just very quickly, we had ferns in the Carboniferous, and they started and they went all the way through the Permian, Triassic, and the ferns stopped being the dominant plants on the planet by the time we get to the Jurassic. They are replaced everywhere by the conifers, specifically the cycads. They took over the land. They displaced the ferns, especially the seed ferns. That's important too. And what happened next? Well, we had a couple 100 million years, not as much as 200, but close to it. We had millions of years of these conifers just spread throughout the land. They were essentially the dominant flora. And little by little, they were replaced by the angiosperms, the flowering plants, the seed plants. Cones replaced by seeds. Seeds are the newer invention of Mother Nature. They're more vibrant. They have better adaptability also, et cetera, et cetera, et cetera. But it's part of the evolution. And today we have ferns, and today we have conifers. But 80% of the flora out there are flowering plants, angiosperms. And part of it is due to us. We cultivate flowering plants. We don't eat conifers. We don't eat ferns. We eat angiosperms. We eat flowering plants. We eat specifically a line known as the grasses. Corn, wheat, barley, you name it. These are the grasses. Okay? And that's essentially what we cultivate. That's what we grow, and that's what we eat. And also feed the animals with that, the ones that we're going to eat later on. Okay? So the issue is that the history of the life on Earth is different plant life. Now just imagine the moment of the crossover, and it's not a neat, clear-cut crossover, okay? We're talking about thousands of years probably here. But the point here is the following. As one type of plant dies down, say the ferns, and the other one, which has been around already for quite a while, takes over the land, the conifers, well, the animals, which are now big and have tied their relationship to the ferns, they find ever fewer sources of food, the herbivores. And instead, you have these weeds. These are weeds for them, known as the conifers. And they say, well, I don't eat conifers. I don't eat cones. I don't eat the leaves, the stalks, anything of conifers. I just eat ferns. And now the ferns are becoming fewer and fewer and fewer. And so what happens? When the ferns were expanding, you have different types of animals occupying different niches. They expand, they radiate together with the ferns. As the world closes in on them and we have fewer and fewer varieties of ferns and fewer numbers of ferns, well, guess what happens to the animals, to the herbivores? Well, they lose diversity as well, and they become fewer in number as well. And at some point, the system collapses finally. And the little animals who were in the background, the dinosaurs, these little mouse-like dinosaurs, now they can expand because the big guys are out of the way. The synapsids, they're out of the way. Now they can expand. Well, in this case, it was really there was an intermediate there, which were the archosaurs. But the point is, the previous types of animals that depended on the ferns, they go away. And the new animals take over the land because they follow the new plants. Okay? So we don't need any asteroid, any volcanic activity to get rid of the older plants. They're going to die. Why did they die? Well, here's the chart that I always put up. So if you look at the chart, you'll get an idea immediately what the theory is about. This is what happens to the plants, okay? Especially. What we have is an overturning of the ecological pyramid. What we have is normal pyramid includes few predators, many herbivores, or you can call them carnivores, and at the bottom we have primary production. And a normal pyramid has a 10-to-1 ratio from bottom up. There should be like 10-to-1 ratio between primary production and herbivores, and another 10-to-1 ratio in general between herbivores and carnivores. That in general is what is called a healthy pyramid, a sustainable one. What happens when it inverts, when the primary production goes away? Well, now the herbivores are having trouble finding this their food sources, and so they start dying off in mass. And what goes next? Well, the predators also have become numerous, and now they can't find anything to eat. They even kill each other. You know, predator eats predator, big guy eats little guy, until they all disappear. And the entire food chain disappears, because that's what a mass extinction is. It's the disappearance of a food chain. And that's how you can explain selectivity, which is what no theory, catastrophic theory, can explain. Not one of them can explain that. Okay? If you hit the Earth with an asteroid, you're going to kill whatever animals you killed with the asteroid, and then you got to explain the guys on the other side of the Earth. And for this, you have to invent new mechanisms. And you say, well, how did the other guys die? Well, they died because you had all this. There are several theories. One is that the asteroid hit the water and caused tsunamis. They drowned the land. Okay? The other one says, you know, all these rocks went up into the air, and you have all this brimstone falling down on the animals and burning them to death and burning the vegetation. Okay, so how did the sea animals die? Well, the way they died is, you know, they say the asteroid hit a pile of sulfur. They were just so unlucky that the asteroid hit, you know, fell on a pile of sulfur and created acidity in the waters, and some of the fish or whatever, you know, in this case the reptiles, could not handle it. Why did the little mammals survive? How did they live without any plants or anything to eat? And the answer is that they ate detritus. In other words, dead animals for 4 or 5 years, until I guess God decided to invent plants again. And if you look at the record, there has been no indication that the asteroid wiped out the angiosperms. The angiosperms had no interruption in their expansion. They just expanded. You would think that the asteroid would have burned at least half, if not all, of the angiosperms. That never happened. And here's the chart for those who are interested in this theory, and the chart says it all. Here, just look at the chart and you'll understand. Here's what is known as the Cretaceous terrestrial revolution. Okay? And you can see that the angiosperms, starting 130 million years ago, started muscling in on the land, and they displaced all other varieties of plants, specifically all the conifers, which is what the dinosaurs ate primarily, and not to mention even the ferns. And we're talking about specifically a specific type of fern, and they never mention that qualitative difference. And the ferns that disappeared are the seed ferns. You know, you have Glossopteris, and you have Dicroidium. And these two types of plants, generic types of plants, they disappeared completely. Dicroidiums disappeared completely at the end of the Triassic. No more dicroidiums. And the Glossopteris, and there were many of them. In fact, so many that there were some regions that only had Glossopterids. And they disappeared at the end of the Permian. And so the question is, you would think that the animals that forged a relationship with the only type of plant around, which was the glossopterids, which disappeared at the end of the Permian at the 252 million years ago, you would think that when those plants disappeared, all animals that had nothing else to eat but glossopterids, they could switch their diet at the last moment and say, well, after millions of years, I think instead of glossopterids, I think I'm going to eat something else. I'm going to start eating conifers, cycads. It's like saying a rabbit can't find lettuce or tomato or whatever. A rabbit eats grass and suddenly has to eat cones, conifers. You think a rabbit would do that, just switch at the last minute and say, well, a veggie's a veggie's a veggie, right? I'll just eat anything I find out there. Do you think a rabbit eats Christmas trees, Christmas leaves? No, of course not. He's got his stomach already built to eat what he forged a relationship with, which is the angiosperms. He cannot switch his diet at the last moment. Neither could the dinosaurs, neither could the synapsids before them, or the amphibians before them. And so, plants will disappear. They disappear, why? Because after millions of years of inbreeding, they lose their genetic diversity, one, and finally their population pyramid overturns. There used to be plants like Cooksonia. I'm talking about Silurian here, millions of years ago. They're no longer around. And they were very primitive plants, and someone must have ate them because there were some land animals. They were just starting to come out. Maybe insects. But someone depended on that food. Maybe, maybe that's how the amphibians grew. They started eating the bugs that ate the plants. Maybe that was the food chain. We can speculate on a lot of theories. The point here is that animals depend on plants. When the plants disappear, after millions of years of relationship, the animal cannot switch his diet overnight. That's the issue. We don't need any catastrophic type of accident, such as asteroids, volcanic activity, or any of that nonsense to produce the extinction of plants. And so the issue is, you will not find a theory that I just explained anywhere in the literature. You won't find it in the Wikipedia. You can look around anywhere you want. And everywhere you will find the trigger. And the trigger is not a natural process. The trigger is some catastrophic accident. That's where we differ. There was no catastrophic accident. There's no need for a catastrophic accident. All we need is the overturning of the population pyramids of plants and the loss of their genetic diversity, which is a predictable process after millions of years of inbreeding. That's it. Now, the problem I've got is that I want to talk about extinction. People don't want to talk about extinction because they know nothing about the animals. They do no research about the animals that existed in the past. They don't know what a synapsid is. They don't know what an archosaur is. And so what's the issue? They want to talk economics. Because I'm talking about the extinction of man. They say, oh, Bill, but you're saying economics, and look, and everybody's an expert in economics. And we have 8 billion experts on planet Earth in economics. They'll talk to you about supply and demand curves, about unemployment. Oh, everybody's an expert. Everybody gives you his opinion in the form of truth and fact. They know everything. They learned it in college, a lot of them, they learned it from Milton Friedman and Keynes and Marx and who knows, all these people. So they're expert. Everybody's an expert in economics, but no one's an expert in extinction. And so I want to talk extinction, people want to talk economics, and that's where the problem is. I'm going to talk about economics as soon as we cover the first base, and the first base is extinction. You have to tell me how the animals died before you have a theory about extinction of man. Otherwise, you know nothing about extinction. You cannot talk about man that has this, and we're so intelligent, and we can do this, and hopefully we get government off our backs, and finally we're free to engage in free trade, voluntary trade. Absolute nonsense. Please talk about extinction, not about man. Show me how the dinosaurs died. Explain that. And if the amphibians, the synapsids, the archosaurs, the dinosaurs, if all these groups of animals disappeared all in the same way, using Mother Nature's cookie cutter, right? She applies the cookie cutter every single time. She gets rid of the plants, the animals die. Gets rid of the plants, the animals die. Gets rid of the plants, the animals die. We got the cookie cutter. That's very simple. We apply it to man. Not really to man. We apply it to the mammals. I don't think man's going to die and all the mammals say, finally, we get rid of man. Lions start expanding again and the sheep and, all these animals start populating the land again. Suddenly, we got rid of that monkey. It's not going to happen. The day we go, we eat everything in sight, just like maybe the T-Rex ate everything in sight. He was the macho guy, and he took care of everything, big and small. He was hungry. And when we're hungry, we're 8 billion people, we're going to eat everything in sight. We're going to be like, like the locust. And so this is the issue. The issue is that, we're going to take all the mammals with us. It's going to be a mass extinction because all mammals are going to go, essentially. Maybe some mammal survives out there for some reason. I don't know. But essentially, it's the end of the mammals. Who comes next? Well, I don't know. Maybe the insect. Some insect that we don't eat, and some insect that doesn't need the flowering plants that we eat. Maybe some insect that eats weeds. Got used to eating weeds, and we go, and so this guy continues to say, I don't know what happened here, but now, free at last. Now I got rid of man, of all the mammals, all the insects that were eating me, and now I can eat my little weed here and survive. Maybe that's what's going to happen. I don't know. I don't care because, at that point, we're not going to be around to think about it, okay? And so again, I want to talk about extinction. And unless you talk about extinction, I'm not even going to enter the discussion. I don't want people talking about economics because everybody's an expert in economics and they fix everything with economics and they believe that you got to get rid of government. That's all you got to do. All these anarchists out there who want to get rid of government because government's getting in the way of their taxes and their freedoms and who knows what else. If we could just get rid of government, we've got it solved. And then we can engage in free trade again. Well, let me tell you something about trade because, I used to be a Marxist. I am a Marxist in the sense that I understand his criticism of the capitalist system. And I think Marx made a good criticism, very detailed criticism of the capitalist system. You got to read his book to understand, where he's coming from. And you got to keep two things in mind. He's talking about the 19th century, and he's talking about the age in which manufacturing is taking off. You've got all these inventions. We're talking about 1850s to 1880s. So we have this increase in manufacturing. Industry is increasing. So his analysis is not with respect to services. People weren't thinking in terms of services in those days. They were thinking of manufacturing, of industry, of material goods. And so if you look at Marx, his Das Kapital, it talks about manufacturing goods. So he does everything with goods. Keep that in mind. But if you look at his analysis, it's a pretty good analysis. Of course, it's a thick book. Not a lot of people are brave enough to read Marx. I read him when I was very young. I was 17 years old, and I ate that book up. And so I have no problem with his criticism. I just have a problem with the ideology today. Communism, it's never going to happen. Extinction is going to happen instead. Okay, so what did Marx say? And you got to listen to this. Marx says that trade does not happen between two individuals, which is what everybody who's in Disneyland economics today, every expert, says, oh, we get government off our back. Suddenly I have all this liberty to engage in trade with my neighbor. Because it's a voluntary transaction and government is not going to tax me. It's just he's got something I like, I got something he likes. We have a voluntary trade and blah, blah, blah. Well, Marx will enlighten you. Says it never happens among individuals, not originally. It happens again within communities. It's communities which develop trade, not individuals. And you say, how can that be? And you got to remember, that's why I laugh at all these people who tell me, Bill, man of Neanderthal and, Homo erectus and all these guys, they engage in trade. We always had trade. What the hell? A basal hunter-gatherer engaging in trade. It shows how deranged people are today. People are so fanaticized about, have this extreme fanaticism about trade. That's all they learn in college, and they apply it to everything. They say trade, 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 trade. You can't get. This is a guy who's rambling, and you can't stop him from rambling because all he understands is trade. He can't imagine that if, assuming humans were around for 200,000 years, that at least for 180,000 years we knew nothing about trade. We had no trade. There were no voluntary transactions. No such monster. And why? First of all, because, it's like Marx says, the guy produces something that he uses. He doesn't produce for the market. He doesn't produce spears and starts, put a stand there and starts selling spears for everyone because he's the great manufacturer of spears. I mean, these people really, that's why they have to study a little more anthropology and a little more paleontology and less economics because they're so, so blinded by economics, they cannot think properly anymore. And no, a hunter-gatherer has no need to trade, and it will not trade. And one of the reasons is security. There's no 911 in the jungle. No judge that can set things right, justice. No such thing. It's you kill the other guy and you take what he was going to trade and his life, and then you eat him also, by the way. You need to feed your family. So the issue here is that, no, there was no trade, and trade starts with communities. Once man became sedentary, as long as he was a nomad, hunting nomad, right? And we're not talking about the guy with camels out there in the desert who trades today. So people confuse that as well. They think the hunter-gatherer of 50,000 years ago, the Upper Paleolithic or whatever, he was the same thing as these guys that go around trading in northern Africa, Bedouins and so on. No such thing. We're talking about basal hunter-gatherers. These guys are monkeys. They're closer to chimps than they are to modern humans. Then you have to have language. Not only do you need sedentary community, but you have to have language. And one of the things that people have is, the anthropologists and so on, they have no idea how language came to be. No idea whatsoever. You hear several theories out there. A lot of them are bogus. They go into origin of the languages of today, but those can be traced only to the Neolithic, and we're talking about maybe 12,000 years ago. I'll give you another 8, maybe 20,000 years ago. Fine. What happened before that? Was it grunts? And you can get an idea from animals. Lions, they have their own language. And their language is not, it doesn't come out of their mouth. It comes through their actions. They convey ideas by their behavior. It's all intuitive for them. And a lot of that had to happen to humans and to our human dynasty. In other words, all our forefathers. They probably, communicated in some way, but within each family primarily. If there was a language in which someone had to teach how to make a spear to his son, or a group had to hunt something, kill some animal, yeah, they could organize themselves. Obviously they did. And the question is, how did they communicate? Certainly there was no writing. Some people might even argue that. I mean, we got all kinds of people out there. And I doubt very much that one clan understood the language of another clan. Maybe they did. Maybe all this intuitive stuff was universal, essentially, because they had a simple life. They only had to make some tools, get their stomachs filled, live one more day, kill something out there. So the world was very small, very routine. And within that, you don't need a lot of language, and a lot of it could have been, through gestures, maybe some sound coming out of their mouths. So you can have all these theories out there, right? No doubt about it. There's a lot to think about there. The point here is that I'm not sure that all these human groups, one over here and the other one over there, they could communicate to each other. We can't even communicate with the Japanese today. They have a different language, let alone these people thousands of years ago. And second, the other thing is they were all enemies. And people have this modern day view that your neighbor is your friend. In those days, your neighbor was your enemy. The worst enemy of a human was another human. Let me repeat that because people have not really grasped that. The enemy of a human is another human. The enemy of a lion is another lion. And this notion that people have that lions kiss and make up and they share their women, their females, no. It doesn't work that way. Not in the wild, not in nature. In nature, it's all death, killing, enemy. So you don't trade. You don't trade with you. You make your own tools, partly because you might even be proud of making your own tools because you make them real good, and that's your tool. You made it. So there could be an element of pride in there. I don't know. Maybe there was that feeling. But for sure, you made your own tools. And then you walked around, you killed some animal, you lived one more day. And whatever grunt you spoke to your wife or to your kids within the clan, that was it. And then, from there, you would say, how did they have sex? Well, they had sex within the group. There could have been kidnapping of a girl on the other side as well. That's very likely too. That's in Marx and Engels' book, The Origin of the Family, the Private Property and the State. So you should read that book if you want to get an insight into that process. That could have happened. And again, these are theories. And the other one is that you do it like the way the lions do it today. The little girl, she leaves the clan, the pride, and a male, when he gets a little big, daddy's going to kill him. So he's got to leave. Not like today, the 30-year-olds stay with their mother and father. No, that didn't happen in those days. In those days, it was like the lion. When you reached a certain age, you probably wanted, maybe the guy had to leave because he created some kind of threat to the patriarch. Or maybe he just wanted to create his own empire. So he finds a girl from that left the other clan. That's how they formed the new clan. They developed their own grunts, maybe. Maybe they brought their own language. Who knows? But for sure, you need language to trade, you need communication to trade. First, there's nothing to trade. You don't produce for the market. There's no such notion. Second, very simple life. You make your own tools, so there is nothing to trade. And then, you have this issue of language, and then you have the issue of security. There's too many barriers to say there was anything such as trade. But if that's what people believe, well, I can't help them. And the other one that I like to talk about regarding, these misconceptions is not only trade, but the other one is clothes. They always dress up Neanderthal with clothes. Well, it's like dressing an elephant with diapers. Have you ever seen a big elephant with his butt covered with diapers? Well, hopefully not. And that's essentially what you're doing when you're dressing up Neanderthal. Neanderthal breaks up from humans, maybe 500, 6,000 years, 600,000 years ago. So, they branched off, probably a little more, I would say. And if you take it back, there was some kind of, at least what it seems like from the record, strictly from the record. There could be another theory, there could be another process going on. All I can tell you is what I can think. And my thought process is that Homo erectus left Africa. Some stayed, some left. And they traveled all over the place. We have Homo erectus in Java, Indonesia, way back east. You have also man of Peking. His skull disappeared, and he was in China. So Homo erectus was in China. But the older humans, or human line, if we consider Homo habilis part of the human line, well, that you can't find anywhere on Earth except in Africa. So my best thought right now is that Homo habilis started in Africa. He evolved into Homo erectus, and Homo erectus started walking the planet. Little by little, after hundreds of thousands of years, one ended up in the east. Another group ended up in Europe. And so the issue here is that Homo erectus, he was in Europe during the glacial period. We had Arctic weather, and not only Arctic weather, it was worse than it is today. The glaciers were all the way down to France. You had not only snow, but you had ice throughout most of the half of the British Islands. It was all covered with great glaciers. And this guy, this Homo erectus, he lived in that weather. And here's the picture. I've got this in my book, but I'm going to put it up here so you can see what happened in the British Isles. And this is out of objective data, okay? And here you see it. You know, you have these sites, and all these sites are approximately in the same place. Someone lived there. And we're talking about, anything between 800,000 and at least 250,000 years ago. You had someone living there, some kind of monkey, okay? Now you could say, well, it was Homo erectus, maybe it was antecessor, maybe it was Heidelberg, maybe it was, and later on Neanderthal. Well, I'm saying Neanderthal originated from these guys. And so when these guys were there and they were hunting game, big game, such as, for example, mammoths, because they find mammoths also in this region. Well, the question is, how did these guys live? And so the issue is, we got a problem if you think that these guys wore clothes. And if these guys didn't wear clothes, because clothes did not come until much, much later, and we think of this also because there are no needles to sew clothes together, and you would need to stitch things together in order to create certain parts. Shoes, they walked on shoes. It's much easier to believe that these prehistoric humans, or human line, these Homo erecti, these Heidelbergs, these antecessors, these Neanderthals, it's much easier to believe that they were nude, completely nude, and they walked in the snow. And you say, how can a human body can't take that? Well, you got wolves today. Look at a wolf. I mean, how much protection does he have? Does a wolf wear a coat? Wolves sleep in the snow. Let me repeat that. Wolves sleep in the snow. They don't die. They don't get a cold. And what they do have is a layer of fat underneath their skin. And that's the protection. And that's the same protection that Neanderthal likely had after hundreds of thousands of years of evolution in Europe, in Northern Europe. So there are no clothes. And there's no evidence of clothes. There's also no evidence that humans ever met a Neanderthal, let alone sleep with him, like Svante Pääbo and all his geneticists say. We have 2 to 3% commonality DNA with Neanderthals. Yeah, and 500,000 years ago, separation, there's your 2%. These people say that we met again 50,000 years ago, had sex, and that's how the Neanderthals disappeared. Idiotic theory. That's what it is. Anyone who believes that really has a mental problem. There's no other way to look at it. Okay, so much for extinction and so much for the Neanderthals and trade. No trade. Forget about trade. There's going to be no trade. When the government collapses, It means there's going to be no money, and when there's no money, companies have no incentive to produce food or distribute it to the cities. And that's not going to be taken over at the last moment and say, oh, look, potatoes are in high demand. I think I'm going to start selling potato, growing them in my apartment on my rug. Sell them out there at $1,000 a pop. Mental problem, severe mental problem. You should see a psychologist or psychiatrist or whatever, right? No, no way. The day that the economy collapses, that's it. No one's going to produce food. And right now, most of the food in the world is produced and distributed by agricultural corporations. They do it for business, they do it for money. No money, no food, no distribution. The whole thing ceases. And so, yeah, we have to explain how that happens, how money disappears. That's a separate issue. That you need to explain. But once money disappears, to say that that's going to be replaced by one-on-one trade, you trade with your neighbor and we're just going to continue another billion years, that's just retarded. That's completely retarded. I mean, if this is what you believe in, I can't help you. You need Valium or something. Something a little more powerful than or electric shocks or whatever. Okay, let me move on. There were some questions about the physics part, and let me just quickly go through that if we can do it quickly. One guy says science is to make prediction of the observable. Beyond that is interpretation. Even quantum mechanics makes no other claim. Well, no, science is not about predicting, and science is not about observing. That's not science. That's mathematical physics, which the mathematical physicists have converted into science. They have equated into science. Why? Because math can be used to predict. If you know that a car is running at 50 miles per hour, you can say, look, in 1 hour, if everything is constant, no change, it's going to be over there in 1 hour. So you can predict. That's math. That's got absolutely nothing to do with explaining. You have no explanation. All you have is a description. And that's what a prediction is. And that's why the mathematicians have harped on prediction, on that word prediction. They say, oh, we can predict. That means we know. Well, what you know is a description. You don't have an explanation. You still cannot tell me how a magnet attracts another. You still cannot tell me what gravity is or how it works. All you can tell me is that you can predict that if I let go of the pen, it's going to drop. And you can predict that if you put two magnets close to each other, one's going to attract the other. And you can tell me even how fast it's going to do it. That's prediction. That doesn't tell me the mechanism. So no, science is not about predicting, and science is not about gawking, which the mathematicians call observation. We don't gawk. You have to understand, not gawk. Anybody can observe. I can observe a pen falling 1,000,000 times. Does that mean I understand or can explain the mechanism of gravity? I can observe how a magnet attracts another 1,000,000 times. I can repeat the experiment and observe, and observe. I got observation. Does that mean I can explain how a magnet physically attracts another, what the mechanism is? This is the issue. The issue is these people cannot explain. Describe, yeah. Observe, yeah, we can all observe. I can observe birds every day. Doesn't mean I understand what they're doing. So observation is not a part of science. Gawking is not a part of science. Neither is predicting. That's not science. Science is explaining. And yeah, a lot of people have trouble understanding the difference between a description and an explanation. They think it's the same thing. They think an explanation is just a series of descriptions or something. And yeah, that's where you have to understand the difference between them. For that, you have to define the two terms. You have to define what a description is, what that word means in scientific terms, not in ordinary speech. That doesn't count. You need to define the term describe or description. You need to define the word explain or the word explanation. And until you can define those two terms, and if you think that, you end up concluding that an explanation is just a bunch of descriptions, well then, you got a problem because they're not the same. Explaining the mechanism of how a magnet attracts another is not a description. Explaining a mechanism is not describing, saying, yeah, the magnet does attract another. No kidding. And yeah, the pen does fall to the floor and falls to the floor at 9.8 meters per second square. Yeah, that's a description. You haven't explained anything yet. And so you need to define these terms to separate them and not confuse a description with an explanation. Math can only describe. And that's why math has become equated to science, because it's the mathematicians who say this. Not because science is like that. Science is something else, especially as it relates to physics. Science is explaining a mechanism. And that's what we don't have today. We don't have for any invisible mechanism of Mother Nature. We don't have it for light. We don't know what light is. I mean, I'm talking about the mathematical physics, right? We do know in science, but not in mathematical physics. Mathematical physicists don't know what light is. They mimic it or simulate it with so-called wave packets, whatever that is. They can't draw it. They just say, here we use the wave and here we use the particle. What is a particle? It's a vibration of a field. So you figure it out. They don't know what magnetism is, how a magnet attracts another. You had Richard Feynman making a fool of himself, Nobel Prize here, right? And he makes a fool of himself saying, well, we can't really explain. You got to take a course in advanced mathematics to understand, how a magnet attracts another at the university. You couldn't explain it, not on camera. And gravity, they're still trying to figure out how gravity works. They're trying to merge quantum mechanics with general relativity because, again, they can't figure out gravity. They invent singularities for black holes. What is a singularity? A zero-dimensional heavy thing. Do we have the mechanism of how a black hole affects something else far away? No, we just say it's mass. But mass is just a description, mathematical description. So all we have is description. We don't have any explanations. That's the problem for invisible phenomena. Okay, here's another issue that was brought up by someone. And he says the difference between theory and physical explanation. No, theory is a physical explanation. Theory means explanation. Theory is not description. Theory is explanation. And until you define what a description is and what an explanation is, you'll never understand the difference between these two. So that's the problem. And he says, unfortunately, many of our best theories will have no physical analogy to understand them by. Yeah, I mean, if you don't explain, no one will understand it, for sure. You got to explain the mechanism, and the explanation should be objective. What do I mean by that? It means you should be able to make a movie. You should keep your mouth shut, show me the mechanism right there on the screen, and I'll understand your mechanism, your proposal. So you say, okay, how does a pulley pull the bucket? Well, I pull on the rope. The rope is tied to this bucket, and it goes around the pulley, and I pull on the rope, and the bucket goes up. And so by watching the movie, you say, well, I know how a pulley works. I can explain it. I understand it. But see, that's not what they do with invisible mediators. When we get into the magnetic field, when we get to the gravitational field, when we get to all these invisible mediators, they draw a blank. And why? Because they want to do it all with particles. And you can't do it with particles. That's the problem. And that's assuming we have classical particles. But when you get into quantum particles, well, all bets are off, because now these guys are saying, well, it's not really a particle. See, a particle is really a vibration of a field, an excited field. It's a bundle of energy, whatever that is. And so that, all bets are off at that point. We have no explanation. Okay, here's another one. And this one's an interesting one because it was along the lines of what we were discussing. That's the ether. This guy says, quantum ether is a mathematical with predictive power. Blah, 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 blah. He says it cannot have material existence. Well, if it doesn't have material existence, then it's not a part of physics. Okay, if that's what ether is to this guy. Now, other people have other ideas of the ether, and I don't know how else to drive the point, but ether means bunch of particles. That's what ether means. Bunch of particles. That's all that ether means. So every time you say ether, it means bunch of particles. And bunch of particles is not a physical object. We don't use what is known as mereology in science. That's religion. A table is not the atoms it is made of. A table is what I point to and say table. A tree is, I point and say tree. A rock, I point and say rock. A rock is not a bunch of atoms. That's mereology. That's what the rock is made of. What is made out of is not a definition of an object. An object is not what an object is made of. An elephant is not the atoms that comprise the elephant. An elephant is what I point to. That's an elephant. Now do it with ether. Well, here, let's do it. And here we have the ether everybody's thinking of. They say, look, here's the ether. Okay, and that's the entire universe there. And here we have two questions. First, is the ether the same thing as the black stuff? Well, obviously not. I mean, if every little particle there is contoured by the black stuff, then the black stuff is something different than the ether, if the ether is the bunch of particles that comprise all that moving white stuff there. So either the ether is that blob, or the ether is the black stuff. In other words, either the ether is space, or the ether occupies space and space contours each ball of ether, in which case you got to tell me what space is. Okay? And so that's the first issue. But the first thing we have to do is stop that motion. Okay? That motion is confusing the person who proposes ether. So let's stop the motion. Okay, here it is. What happened here? Let's see if I can get it back here. Oh my God, let me get that better. Give me a second here. We'll get your ether in 2 seconds here. It was too expanded. Here's the ether, okay? Yeah, we stopped the motion so it doesn't disturb your eyes. Now we have static ether. Is that the ether, a bunch of balls? Is that what the ether is? Is that what you're going to set in motion? And again, we have the issue is whether the black stuff is the same thing as the white stuff. Obviously not, because we have two colors there. So we have to identify the two things we see in that image. The black stuff is not the same thing as the white stuff, the white balls. Okay, so so here we have the ether without the little balls. That's the ether. The ether is just a big blob. We don't care what it's made out of. So if the ether is a bunch of little balls, that's not an object. The only way the ether can be an object for the purposes of physics if we considered it as a whole. And of course, when you do that, the ether is worthless, because what the guy wants to do is say that, what is light? Well, he says it's the wiggling of the ether, okay? And so he has this thing in mind. He says, look, here's the ether. That wiggle, that's light. It's the wiggling of the ether in one localized region of space or whatever. And you say, hold it. You went too fast. We got to start at what the ether is before you start shaking it. And again, before you can define the ether, you have to look at what an object is. An object is that which has shape, not that which is made of particles. And the ether is that which is made of particles. That's the definition. And this is really an object. The ether would qualify as an object if you take the whole shebang. And the ether is not this. This is not ether. That's a bunch of particles. That's not ether. Now, it's not an object for the purposes of physics if you're going to define the ether as a bunch of particles. You can only define the ether as an object if you look at this, just the outer contour. That's an object for the purposes of physics. And yeah, you can't do much with it because, you want to try to vibrate something in the middle there, and that's what you're going to call light, and that's your wave there. So this is the problem. The problem is that the person wants to get away with murder and doesn't understand the foundations of physics. The foundations of physics is you have to define the word object. And that destroys all religions, like I say. Once you define the word object, God dies, space-time dies, ether dies, electricity dies, plasma dies. And when I say that plasma and electricity die, they die as objects. You can't use them as objects. They're not what we call a physical object in physics. They're concepts. You can't use a concept. You got a jumping kangaroo. This is what you're proposing. You're saying, let's see if I can find it here. I guess not. Yeah, here it is. this is what you're saying. You're saying that your ether and your electricity and your plasma and all the nonsense that the electric universe proposes, that's the guy on the right. And that's not a physical object. That's a jumping kangaroo, and a jumping kangaroo is not a physical object. Sorry. The object is the guy on the left. You don't have motion there. You have to think of an object as the only object in the universe. So if you talk about a cube, it better not be moving. If it's moving, it's not an object. It's a moving object. And that's what electricity is, a moving object. And that's what plasma is. It's a moving object. And we care about the object, not about the moving. So you can't use the word plasma in science, in physics, to do anything with it. You can't use it as a baseball bat, because it is not a baseball bat. Plasma, electricity are jumping kangaroos. And until you understand that, there is no possibility of even a discussion. That means you don't understand the foundations of physics. You still have not gotten through that step. And yeah, I know it destroys your religion. You're going to hang on to it and say, well, Bill, go to hell. I'm going to continue believing my stuff. Okay, fine. Go ahead and believe your nonsense. But you can't use the word plasma. The other problem with stuff like plasma is that it's total idiocy. And what is total idiocy about plasma is the fact that plasma requires gas. You need to ionize the gas in order to produce plasma. Another reason why plasma is not an object, standalone object. Plasma is something happening to a gas. That's what plasma means. But you need the gas. And, for those who done plasma like me, I worked with plasma many years. You need to take it to, I would say, at least a -3 level if you want a -3 torr. In order to produce electricity, do something with it, And, the electric universe produces these filaments. And they say it's electricity going through the plasma from one planet to another, from one star to another, from one galaxy to another. Utter nonsense. Utter nonsense. That means this guy is proposing that all of space is filled with gas. And you have to have at least, I would say, at least -3 torr level throughout space. That means all of the universe is covered with -3 torr level of gas. And that's absolute nonsense. Here in the solar system, just, one place where we've measured it. We measured it on the moon. We measured it also here in space. And we measure -11 torr. That's the environment of the solar wind. So if you're on the moon, no, sorry, you won't be able to breathe. That's why you need this thing there, That's the first one. But the point is that, they measured the vacuum on the moon, pressure on the moon, whichever way you want to look at it, -11 torr. And you cannot produce this filament that binds galaxies with -11. And out there in between galaxies, it's regarded to be anywhere between -16 and -19 torr. In other words, there's one particle every 100 kilometers. There's no particles out there. It's almost total vacuum. And then you get to what is electricity. And at that point they say, well, you got all these electrons flying through space. That's not what electricity is. If you think that electricity is an electron bead that goes from atom to atom, not only are you introducing quantum nonsense, idiocy, but that's not what electricity is. Electricity is something else. And that's another class, another lecture. Electricity is not the jumping of one bead from one atom to another, as has always been regarded, at least since the 19th century and 20th century. Utter nonsense. There is no such thing as a discrete bead that jumps from one atom to another to create this flow of current, as they call it. That's utter nonsense. Okay, with that, we'll see you on Sunday. Hopefully I'll feel a little bit better. And you can throw all the stuff you want at me. I know there's people whose religion just been offended. and they'll want to strangle me, you know. And, okay, we'll see you on Sunday. Bye-bye.